In this part, we will prepare everything for game elements rendering. It involves writing a function to project distances and coordinates onto the screen, and functions that will create ready-for-use canvas context. We need to somehow project game state to the screen. To do this, we are writing a function that receives container and game field sizes to return an object with two projectors, one for distances and one for vectors. To find out how much pixels needed to represent size of the game cell, we first calculate width ratio and height ratio. And by taking smallest of them, we can have unit on screen. 1 unit of screen equal 1 unit in game, and unit in game is cell. So when we knew this value, we can project distances. In order to project distance, we only need to multiply distance from the game on unit on screen. And to project position, we receive in position that's represented as a vector, and by using scale by method, we can receive a new position. Now let's check these functions. We add in console log and comment out set interval. Let's re-render, and here we can see two functions: project distance and project position. Now let's go back to the code, return everything to the previous state, remove console log, and now we're ready to implement render. But first we are going to take everything we need from the state. From the game we need to know width and height, position of the food, coordinates of the snake, current score, and from the app state we need to take best score and also two functions for projecting distances and vectors. So first let's calculate width of the view, and view is our canvas. To do so, we map our width and height with project distance. Now we have size for the canvas in pixels. Then we want to receive context of the canvas. To do so, we are calling getContext function, in which we pass width and height. This function will receive the size, and what it's going to do? First, this function will take an existing element of container. So there's two cases: is canvas exist, and if there is no canvas. If there is no canvas, existing will be equal to undefined. So canvas will be equal to existing if it exists, or we are creating a canvas element. Here we pass name of the element. If container haven't had canvas element, we need to add it. So we check if there is no existing element. We are calling getContainer function, and we are append child method. We attach canvas to the container. The next step is to get context, and we can do this by using getContext method of the canvas. Then we are going to clear everything in the canvas. We are doing this because getContext function will be called on every render, and we need to clear everything before rendering all of the game elements. We are doing via clearRect method. Then we are setting width and height. because this function can be also called on resize handler. So if written h should be changed, we are changing it here. And finally, we return context. Then we want to have something similar to unit on screen. This will have the same value as unit on screen. We're doing this by dividing width of the view on width in the game, and then we call functions that will render particular parts of the game. So first we render cells, then we render food, and after this we will render our snake, and finally we'll render current and best score. In all of this function we pass context, cell side. For example, for snake and for the food we need to project positions first, and finally we want to render score. It receives current and best score. We won't implement these functions right now. We will do this in the next part, but for now we are simply going to create empty functions that we will fill in the next part. We are done with our functions. Now we can check our canvas element. To do so, we comment out, send interval, and call the tick method. Now let's go to the browser, reload it, and we can see our canvas with this nice border. We specified border in CSS part. Every time we change the size and reload page, we can see that it fits very well on the screen. Check out my app at increaser.org, designed to help you stay focused, make work done, keep progress, see if you give enough time to projects, and find unproductive patterns. By working with the app, you will build discipline and self-accountability that are required to succeed.